Okay, so good morning everyone. So today we're going to discuss equations leading to linear equations. Okay, so in this topic there are three subtopics, which is this there are equations that are in fraction form or fractional equations. There are also equations that involves radical, and there are also equations that involves literal. Okay, so we're going to find now the um, equations that will lead to what? Linear equations. Okay, so without further ado, we're going to start with, okay, so we have here uh, the first problem. So these are equations that are fractional. Okay, fractional equations. Okay, fractional equations. Okay, so the first problem, so we have x all over x plus 2, and then you have plus x all over x plus 1 is equals to 2. Okay, so this is our first problem. So how are you going to solve this one? Okay, so actually if you're going to do this one, this will result to quadratic. Okay, quadratic equation, but later on the quadratic equation will be eliminated, and then that will form now a linear equation. So in this case, what we're going to do is we're going to multiply the denominator. So you have x plus 2, okay, times x plus 1, and then this one will be multiplied to the denominator of your two terms, which is x plus 2 times x plus 1 divided by x plus 2, the first term. So x plus 2 will be cancelled, so what remains is x plus 1. So x plus 1 will be multiplied to your x, so therefore that will become x times x plus 1. Okay, plus, so you have x times, okay, again divide x plus 2 times x plus 1 divided by x plus 1. What remains is you have x plus 2. Okay, and that is equivalent to 2. Then we simplify. So x times x, that will give us what? X squared plus x, and then plus x squared plus you have 2x all over, you have x squared, okay, plus x plus 2x, and then you have plus 2, and that is equivalent to 2. And then again we try to simplify this one, that will become x squared, okay, x squared plus x squared, that will give us 2x. Okay, so that will give us um, 2x squared, okay, and then plus 3x, and then we try to cross multiply the denominator to the other side, and then we also simplify that one, so that will give us 2 times x squared, x plus 2x, that will become plus 3x, and then you have plus 2. Okay, so therefore it will now become 2x squared plus you have 3x, and that is equal to, you have 2x squared plus 6x plus 4. Okay, then we transpose similar terms, so that will give us 2x squared minus 2x squared, okay, that will become negative, and you have plus 3x minus 6x is equals to 4. So x squared will be cancelled, what remains is x. So 3x minus 6x, that will give us negative 3x is equals to 4. So therefore your x now is equals to 4 over negative 3, or x equals to negative 4 over 3. So this will now be your final answer. Okay? Okay, so let's proceed to the second example. So the second example is 7 over, you have x plus 3, and then you have plus 3 over x minus 1. and that is equals to, you have 7x plus 8 all over, you have x squared plus 2x minus 3. Okay, that is now the given equation. So solving this one, first we're going to get the denominator of the two terms of the left term, no? So you have x plus 3 times x minus 1. Again, we divide. So cancel ang x plus 3. So what remains is x minus 1. Okay, plus you have 3. Cancel ang x minus 1. What remains is x plus 3. Okay. Then that is equals to 7x plus 8 all over x squared plus you have 2x minus 3. Okay. Then simplify. So you have 7x minus 7 plus you have 3x plus 9 all over x squared. Okay. X squared, and then you have minus x plus 3x, okay, minus 3, and that is 7x plus 8 all over x squared plus 2x minus 3. Okay, then simplify. So 3x plus 7x, that will give us what? 10x, and then negative 7x plus 9 will give us positive 2 all over x squared. Then negative x plus 3x, that will give us plus 2x minus 3. Then you have 7x plus 8 all over x squared plus 2x minus 3. Now if you notice that the denominator are the same, so if we are going to cross multiply that one, so that will be cancelled. So what happens here is cross multiply that one, so 10x plus 2 times you have x squared plus 2x minus 3 all over you have x squared plus 2x minus 3, and that is equals to 7x plus 8. So therefore x squared plus 2x minus 3, this will be cancelled. So what remains is you have 10x plus 2 is equals to 7x plus 8. You transpose similar terms, so that will become 10x minus 7x is equals to 8 minus 6, or this will become 3x is equals to okay, this is 2, sorry. Okay, this is minus 2. Okay, minus 2, so that will become positive 6. So x therefore is equals to, you have 6 all over 3, or x is equals to 2. Okay, so this is now your final answer. Again, when you are going to check if your answer is correct, what you're going to do, you're just going to substitute the value of your x to your equation so that you will know if your answer is correct. Okay, okay, so let's proceed to the next example. The next example involves radicals. Okay, so example number 1, so you have 9 is equals to the square root of 12x minus 27. Okay, so the equation now involves a radical sign. So what we're going to do in order for us to get a linear equation is that we're going to remove the radical sign. So how are we going to do that? So to do this one, we're going to perform the SPS. You know what is SPS? That is squaring both sides, or square both sides. So therefore in this case, we're going to square the two sides. So you have 9 squared is equals to the square root of 12x minus 27, that is being squared, so that we can cancel the radical sign. So 9 squared is 81, that is equals to 12x minus 27. So 12x now is equals to 81 plus 27. You have 12x equals to 108. So x therefore is 108 all over 12. Okay, so therefore 108 divided by 12, x now will give you the value equivalent to 9. Okay, so that is now your final answer. Example number 2. So example number 2, so we have the square root of 4x, okay, minus 3, and then minus 2 square root of x plus 1 plus 1 is equals to 0. Okay, so here we have two radicals involved. Okay, so what we're going to do, we're going to transpose one radical to the other side. So it's up to you what radical you're going to transpose to the other side. It could be the square root of 4x minus 3, or it could be the square 2 the square root of x plus 1. Okay, again you're going to perform the SBS, or the squaring both sides. So for me, I prefer the negative sign, so that with transferring that to the other side, it will become negative. So in this case, we have the square root of 4x minus 3, and then plus 1 is equals to, okay, 2 the square root of x plus 1. So the 2x plus 1, I transpose it to the other side. Okay, and then we perform the SBS. Okay, squaring both sides. Okay, squaring both sides, that will give us, if you're going to square the square root of 4x minus 3, so what remains is 4x minus 3. And then twice the product of the 2, that will give us plus 2 times 1 times the square root of 4x minus 3. And that is plus 1. And that is equals to, squaring both sides, so makancel ang square root, then square the 2, that will give us 4 times x plus 1. Okay, so simplify. So you have 4x minus 3, and that will give us plus 2 square root of 4x minus 3. And then plus 1 is equals to, simplify, 4x plus 4. Then we're going to transpose to the other side the similar terms. So transposing that one, so what remains here on the other side is the 2 square root of 4x minus 3. Okay, and then transposing that one, that will give us what? 4x, okay, minus 4x plus 4, then plus 3 minus 1. Okay, so you have 2 square root of 4x minus 3 is equals to, you have to cancel ang 4x minus 4x, so what remains is 4 plus 3 plus 1, that will give us what? 6. Okay, 6. Again, since we still have the radical sign, we're going to perform the SBS. Okay, squaring both sides, that will give us 2 square root of 4x minus 3. Okay, that is squared is equals to 6 squared. So cancel ang square root, so what remains is, okay, square the 2, it will give us 4 times 4x minus 3, and that is equals to 36. And then we can distribute, that will give us 16x, then you have minus 12 is equals to 36. Transpose your constant to the other side, that will give us 16x equals to 36 plus 12. So therefore 16x equals to 48, and then x therefore is equals to 48 over 16, and 48 is divisible by 16, so therefore we can get your x is equals to positive 3. Okay, so that is now your final answer. Okay, let's proceed to the next equation, which involves what? Literals. Okay, so the first problem is, you have ax minus b is equals to cx plus d. Okay, then what we're going to do, find your d. Okay, find d. So to solve this one, okay, again we're going to combine similar terms. Now since we're going to find d, so what we're going to do is we're going to transpose your cx to the other side, so that what remains to the other side will be your d. Okay, so you have ax minus b minus cx is equals to d. So therefore your D is equals to, okay, combine similar terms, you have AX minus CX minus B, or D is equals to A times ano, so um your common term is your X, so therefore you have X times A minus C minus B. Okay, so this is now your D. That is now your answer. Okay, so let's proceed to the second example. So the second example is D is equals to, you have P times 1 minus M all over, you have 1 minus C, and then we are going to find M. Okay, find M. So what we're going to do here is we're going to cross multiply, so D times 1 minus C, and then distribute your P, that will be P times 1, that is P, and then P times M, that is minus PM. Okay, then we transpose your P to the other side, so that will become D 1 minus C minus P, that is equals to negative PM, or negative PM is equals to D times 1 minus C minus P. So M therefore is D 1 minus C minus P all over negative P. Okay, so I will accept already this answer. If your answer is like this, then that will be accepted, or you can have it simplified this way. So M therefore is equals to D, then you have 1 minus C all over negative P, okay, and then plus, of course, negative P divided by negative P, that will become positive 1. Okay, so you can have this as your final answer. Okay, so that is the examples of equations leading to linear equations. So if you have clarifications, questions, and suggestions, you can post it in our LMS. Okay, and then don't be shy to ask questions there. Okay, so I'm willing to answer all your questions sa ato ang LMS. Okay, once again, thank you for listening. Good day. Have a nice day, everyone, and God bless.